Okay, now we're going to talk about solving parallel circuits. And there's a couple of things that are different. If you remember from series, there was only one path for the electrons to take. And you knew that the current was the same everywhere. For all resistors, the current was the same. For parallel, there's different branches. The electricity coming out, the electrons coming out of the battery have more than one path. They get to junctions where they can take a different path. And then they all join up again here at the end, and it all goes back into the battery, from the negative to the positive into the battery. And we knew for the resistors in a series that we could just add all the resistors. But you can't do that in parallel. What you have to do is you have to take the reciprocal of the sum of the reciprocals. It's just different. It's nothing you can't do. We still have Ohm's law, where the current is equal to voltage over resistance. We're going to be dealing with the same four questions. What's the current through each resistor? What's the total current? What's the voltage through each resistor? And what's the total or equivalent resistance that the battery is feeling from this set of, in this case, 3 parallel resistors? Again, the battery doesn't know there's 3 resistors. It's feeling a resistance. We want to get what it would be the equivalent of 1 resistor. Okay, and remember, for parallel circuits, voltage is the same everywhere. Okay, so again, we have these questions. We may not be able to solve them in order, but we certainly have enough information to get some of them. It's always nice if you can to get the total equivalent resistance, what resistance the battery is feeling in total. And what we do is we use this equation right here for parallel circuits. So what we will do is we will replace R1. Our resistors are 1 ohm, 2 ohm, and 3 ohms. So we have 1 ohm, 2 ohms, and 3 ohms. And remember, we need to take the reciprocal of the sum of those reciprocals. So I get out my calculator here, and I'll take the reciprocal of 1 plus the reciprocal of 2 plus the reciprocal of 3. I get 1.833, and I will take the reciprocal of that, and I get 0.545. So 0.546 ohms is the equivalent of all 3 of these resistors if they were just 1. And it's okay, I know this is less than any of them, but the total resistance is always less in a parallel circuit than any one of the resistors by themselves. Okay, so now we know the total voltage. Voltage total is 18 volts. We have the total resistance, so we can find the total current using Ohm's law. Current is voltage over resistance. So the total voltage is 18 volts. The total resistance is 0.546 ohms. So I'll take my 18 and divide it by, and get that the total current is 33 amps. Okay. That means there are 33 amps of current flowing through here. But some of it goes down each branch. It passes through, and in the end here, it's still the 33 amps flowing through at the end, but we need to eventually find out how much amperage is flowing through each resistor. Just to start to think about it, the third resistor has a greater resistance, so it should have a lower amperage than resistor 2 or resistor 1, which should have the greatest amperage because it has the least resistance to the flow. Okay, so we can go ahead and do this. We need to figure out what we can find next. Here, we can either find the current or the voltage. I don't think we have enough information to find the current, because to find current we need voltage at each resistor, as well as the total we need current and resistance. But what we can find is the voltage across each one. Now, if you'll remember, in parallel circuits, voltage is shared. It's the same. So if we have a total of 18 volts in the system, I know that it's 18 volts everywhere. So now I know the resistance and the voltage across everything, so I can find the current through each and every one. Remember, current is voltage divided by resistance. So in this case, for resistance 1, it's 18 volts divided by 1 ohm, or 18 amps. For 2, it's 18 volts divided by the 2 ohms, or 9 amps. For resistor 3, it's 18 volts divided by 3 ohms, or 6 amps. And again, this should make sense. The highest resistor should have the least amount of current flowing through it, and the weakest resistor, the one that resists the flow of electricity the least, should have the most current passing through it. And just to check here, we know that the total is 33 amps. If I add these up, I get 33 amps. So the total amount of current flowing through each resistor equals the total amperage in the system.